ప్రాబ్లమ్ అనిపిస్తుంది. అండ్ ఇంకొకటి మన ఇంటర్న్ స్టైపెండ్ అప్డేట్ చేయొచ్చు.
Yes, good afternoon all. Can you please confirm? Can anyone please confirm if I'm audible? Yes? Okay, cool guys. Let's wait for a couple of more minutes until everyone joins. And between this time, if you have not had your lunch, you can grab something by your side and then you can have it. Okay? Because I don't want anyone to sacrifice your lunch for the classes and all. Okay? Okay, so let's wait for a couple of more minutes until everyone joins. Wow. Yes, hope everyone are here. Yes, hello guys. Is this session? Yes, I haven't started the session. Hope I'm audible to each, right? Can you please confirm with the thumbs up? Yes, and did you guys check the Google Drive that I shared? So in that I have shared the what is that Python code for KN and decision tree, and also the last one SVM. Did you guys check that? Yes. So for the past two classes, what we have done, what we have learned is we have learned about classification, its algorithms, and excuse me, and also its code implication, right? Now, as some of you have requested me to teach about regression, so what I'll do is I'll just give you a glimpse of introduction of regression. Then followed by that, I'm going to start up with unsupervised learning. Okay, but before that, I have been telling you that I'll be sharing the what is that numerical calculation for KNN, right? So I have done it on my Windows whiteboard, Microsoft whiteboard. So let me share it to you. Just confirm, okay? Once you're able to see it. Are everyone able to see my screen? Yes, guys. Okay, cool. So in KNN, why do we use this KNN? So this is K nearest neighbors. So depending on the new data point that we're going to have, we're going to find the nearest, what is that, class. Okay, either it can be depending on the distance, we will be able to classify, either it can be class A or class B. Okay, so in this example, hope I'm audible, right? And just a moment. So let's get on with this numerical calculations. So here you go. So here is your data set that you can consider. Okay. So please bear with me as my handling is not that good. Okay. But given that all the things that I've written, it can be readable and understandable. So here, what do we have, guys? We have x1, x2, and then y, right? So in terms of x1, we have sleep, x2 is as connected to energy levels, and y is nothing but the gym. So depending on your sleep and the energy level, we will be classifying that has the person has gone to ready for gym or not. Okay, is it clear? So here we have these sleep and then energy levels are there, right? So these are our independent variables. So while these are the independent variables, right? So while coming to gym, these are the dependent variables, which is dependent on these sleep and then energy level. Is it clear? So now what we will be doing is, so here we have how many samples we have? We have 6 samples. So depending on this, what we will be able to do is, here we, since there's a binary classification, right? Here we have only 2 classes, either yes or no, isn't it? So this yes or no can also be converted to 0 and 1 by using on hot encoding, right? So now, what if we have a new point? Okay, what if we have a new point called as 6 comma 6? So 6 represents the sleep, and and the other coordinate represents the energy level, right? This is the new data point that we will have, and now we want to find the what does this 6.6 come under? Does it come under yes or no? That is 1 or 0. Is it clear? So if you want to find that, we have to have the distance formula, right? So how we are going to do it is, so whatever we have, so just me zoom. Yeah. So whatever the new point that we have, that is 6 comma 6, that is the x1 and then y1. These are the x coordinate. That is the coordinates for our new data. Okay. And whatever we have, 6 comma 7, 5 comma 6, 7 comma 8, these are all our old data. This is from the actual data. Okay. So these are all x2 and then y2. Is it clear? So now what we have to do is we have to find the distance formula, right? With this new data. So how are we going to do it? It's clear about x1 and y1. So x1 and y1 are nothing but this 6 comma 6. So x1 is nothing but the sleep's coordinate, that is 6, and y1 is the energy level, that is 6. So with this given new data point, we will be able to, what is that, classify depending on these data, does it belong to yes or no. Okay, that is when the person this energy level 6 and sleep level of 6, sleep level of 6, will he be able to go to gym or not? Okay, so to find this class, what we'll be doing is we will be finding the distance formula. So what is the distance formula? It is the square root of x1 minus x2 the whole square plus y2 minus y1 minus y2 the whole square. So here x1 and y1 are nothing but the new data point that we can consider, and x2 minus y2 are nothing but the data point that we have from the data. Okay, here we have like 6 comma 7, right? These are all our x2 is 6 and y2 is 7. It's clear. So now what we will be doing is we will be finding the distance formula. Okay, let's consider for a. Okay, a is nothing but the first row that we can consider. Okay, so what are the first row that we have, right? That can be called as the first row. So in case of, let me zoom in a bit. Yeah, so what is the value of x1? X1 is 6, right? And what is the value of x2? X2 nothing but this value. Is it clear? So that is 6 minus 6 to the whole square plus what is y1? Y1 is 6. And what is the value of y2? Y2 is nothing but this data point. So you can consider x1 and x2 as these point, that is 6 comma 6, and x2 minus y2 is nothing but these coordinate, that is 6 7 5 6 7 8 4 4 8 9 and 5 6 5 5. Is it clear? So what are we trying to do? We are trying to find the distance, okay, by having this distance formula. Is it clear? So for the first row, that is sleep with the value of 6 and energy level with the value of 7, we will be having this and finding the distance with our new data. Okay, so x1 is 6 minus 6, that is the sleep level, and we are going to square it and then sum it up with the y2, y1 and then y2. Is it clear? So now the value we have got is 1, isn't it? So in the similar way, what you will be doing is you will be doing with the b coordinate as well. So what is the second row? That is 5 comma 6, right? 5 and 6. So what is your x1 value is 6, and what is your x2 value? This is 5. It's clear. So in the similar way, you're going to do it for y2 as well. So what is the value of y2? Y1 is 6 because this is our y coordinate from our new data, and y2 is nothing but the 6 from our energy levels, right? So you will be calculating similarly for these 6 rows. So for each row, what I have considered is I have considered A, B, C, D, and E, F. Okay. So you will be finding the distance formula, right? So next, what you will be doing is you will be first identifying, are you going to consider the first 3 neighbors or the first 4 neighbors? So in this case, what we are going to do is we are going to find from this distance formula, we will be selecting only the values that are very less. Okay. In this case, what are the 3 clusters? What are the 3 values that are going to consider? So you're going to consider A, B, C because these are all these low values, right? So in this, we will be checking the class. So what does this first row come under? It has the first row, that is 6 and 7. What is the output? It has yes, right? That means that he will be going for the gym, right? Next, we are going to get into the B. So what is the B value? It is also 1. Now what is the B value? That is 5 comma 6. What does it represent? It says that, understand that first we have to find the distance formula. After finding the distance formula, we will have to set the clusters. Sorry, we will have to find the k values. K values are nothing but how many neighbors are you going to consider. Okay, it's clear. In this case, we have considered only 2 values. Is it clear? Sorry, 3 values. So we have to find the least, what is the minimum value with the distance. Okay, so after we have chosen these 3 k values, next we have to find how in each of these k values, how does it belong to? Does it belong to yes or no? Does it belong to 1 or 0? And then after we are going to find out next. So what does that A come under? It shows that with the A coordinates, we are able to see that the energy level of with A coordinates, it is showing that that person is going for gym. Okay. What in case of B? What in case of B? Does he goes to gym? So B coordinates are the second one, right? That is 5 comma 6. So does he have to go? Is he going for gym? No, right? So he belongs to no class, that is 0th class, isn't it? So what comes the last one? That is what I have considered. So A with the coordinates, it shows that he is going to go for job. So B with the coordinates shows that he won't go for the job. He won't go for the gym. Next, F coordinate is what? F coordinate is what? What does it show? It shows that F is this one, 5 comma 6, right? 5 comma 5. So it shows that he won't go to the zen with these coordinates, that is 5 comma 6. Is it clear? So among these three, so what is the majority? We have no, right? Isn't it? So hence, with the given data point, we have considered here 6 comma 6, right? It shows that we can also assign the 6 point to this no class itself. That is, with the coordinates of 6 comma 6, we will be having to get to know that he won't be going for the gen. Is it clear? So this is with respect to classification. Is it clear? Now, it is the same thing with the k-means in regressor as well. What we will be doing is we will be doing the same thing, and at the last, here we have considered the majority voting, right? So whichever has the maximum repetitions or voting, you're going to consider that class for the new data point. So what in case of regression, you're going to consider the average of these three. That is 1, 1, and 1.41 is there, right? So whatever the value you're going to get by finding the average, that will be the new value for your regressor. Is it clear? Is it clear, guys? Well, let me tell you from first. So first, initially, you will be having your data set. Okay. So here you will be having your input variables and your output variable. Now, if you have to find the class for the new data point, you have to find the distance formula, okay, with the new coordinates. Okay. So after finding the distance formula, you will be having given a value, right? So in this value, you have to choose the least average value, least value from your distance formula. Okay. But before that, what you have to do is you have to consider the clusters, like how many neighbors are you going to consider. Okay. So depending on that, you have to choose that less number of value. Then you also have to compare. So with these clusters, so with these neighbors, what does these neighbors belong to? Does it belong to A, or does it belong to B, or does it belong to yes or no? So from once you have got these outputs, you have to find the majority one. So whichever is the majority one, then you can consider that new point as that particular class. Okay. In case of mean, that is k-means. In case of regressor, what you will be doing is you will be finding the, instead of looking for the majority one, you will be finding the average, that is the mean. Is it clear? Hope it's clear, right? So in case of classification, you will be choosing for your majority voting. Okay, whichever has the repeated mostly, you're going to consider the same thing for the new data point. But in case of regressor, you will be finding your mean. Is it clear, guys? Hope I am clear. आवाज चली गई. Is it the same with everyone or only? Clear voice? नहीं गई. So in case of regression, you will be having the output in terms of continuous numerical value, right? Like predicting the house of the price depending on the number of the bedrooms and bathrooms, like the square foot and all. So you will not have what is that, a particular class. Here you will be having different values, like continuous values. So in that case, in case of this k means, what you will be doing is you will be finding the mean, right? Isn't it? So that is the answer for the new given inputs. Is it clear? Oh, sir, audio is clear. Okay. I hope it's clear, right? So regression, yes, for regression, you will be finding the average, and for classification, you will be finding the majority voting. Is it clear? I hope it's clear, right? As this is very important, I just wanted you to guys to know about this. I hope the classification part is clear, right? And I have also given the notes as well. If you just go through the drive that I've shared, I've mentioned the readout as well. So every day, whatever we are going to learn, I'm going to share the readout. And I did upload the Google Colab notebooks as well. So here in that, I have mentioned clearly the step-by-step for each cell, what am I doing and what is the need for doing it. I've mentioned it. Okay. Meaning, just listen to me. First, you will be having your data, right? I'm explaining once again. Please listen, guys. So classification comes under what? Supervised learning, right? So here you will be knowing you will be training on a label data set, right? So initially what you'll be doing is you'll be training on this, okay? So now you have got a new point. Now you want to find what does this 6, 6 with the what is the value of 6 for sleep and energy level value of 6. So will I be able to classify, does he go to gym or not? Okay. So if we want to classify, you can go under this K means what is that? KNN. So what is this KNN is? You will be able to find your nearest neighbor. Okay, whichever the neighbor who's closer to you, you will belong to that person or that class. Is it clear? So to find that, what I'm going to do is I'm going to use this Euclidean distance. Okay, so after using this Euclidean distance, you have to find the you have to find the distance with the new coordinates with the data point that you have. Okay, for each values. So once you're going to find the value for each of these distances, now you have to, in case of, you have to make sure, right? Are you going to consider four neighbors, or are you going to consider only two neighbors? In that case, you have to select first, choose this k value, that is to choose your number of neighbors. So once you have selected the number of neighbors, then what you have to do is you have to choose the, if you consider k value is 3, you have to consider only 3 coordinates. So from these you have to select the lowest one. Okay, so which are all having lowest value, you have to find it from the 3 coordinates from the distance value that you have got. So after you have got this, you have to look at the class. Okay, you have got the distance, right? After you have got the distance, you have to check what does this A, that is the first row, belong to class. So it belongs to yes, right? So that is what I have done. So what does this B? So what does this B? Don't worry about this one value. Is it clear? You don't have to worry about the one value. You are only going to choose the k value given the least distance value. Is it clear? आप distance क्या क्या कम है उसको लेना है. Okay, but before that आपको choose करना है कितना neighbors आप चुन सकते हैं. Okay, चुनने के बाद you have to see. Okay, what does this first cluster, what is the what does the first neighbor belong to? So what does the second neighbor belong to? What does the third neighbor belong to? And based on this, you will be able to find which is the majority one. You're going to choose the class for the new data point. So here I've considered, here I've got to know that I have got to know what are the three neighbors that I can consider depending on the distance value. Okay, after getting to know, you have to check. So what does this A, what does the first coordinate belong to? What does this B coordinate belong to? What does the F coordinate belong to? So once you've got to know the output, then from the majority of the classes, you have to give this for your new data point. Is it clear? So this is what happens in case of classification. That is majority. Whichever is repeated most, that will be given for the new data point. But what in case of regression? Regression, you will be finding the average again. Is clear? 1 plus 1 plus 1.41 plus 3 divided by 3. So whatever the value that you're going to get, that will be the value for this new data point. That is regression. Is it clear? I hope it's clear, right? Yes, you have to find the distance formula with the new data point that you have, with all the data point that is being given from your data set. Is it clear? Then only you will be able to find the distance, right? How much far are you from the new data point? Then you have to choose your classes. First, you have to identify what are these distance formula, where does it belong to. Then after that, whichever is repeated maximum, then the new data point will be given that class. Is it clear? Okay. I hope it's clear, right? Now, let's dig into regression concept. So as you have already been known with regression, so I want you to teach me what is about this. Yes, Shreya, for classification, you can consider the mode or the majority voting or the majority classes that you're able to see. And for regression, you have to consider the average. Is it clear? Okay, great. Yes, guys, now tell me, what do you understand by this term regression? I know you have been known with this regression topic a lot, but now you teach me about this regression concept. Yes, cool guys. Now, can anyone please give me any kind of real life example where you can observe this? Let me share my screen. So, use for finding the average, predicting the numerical values, correct? In space science. Okay, let me share my screen. Yes, guys. Hope my screen is visible to all. Can you please confirm? Yes. Okay. Okay, in shapes, level ratios, we estimate the distance and other properties as stars in plus. Okay. So whatever you have told, it's all correct. Amen. So we're going to get into this regression concept only when you want to find when your output is first thing is it comes under supervised learning where you will be knowing your what is the input and as well as your output. Like you will be mapping your input along with your output, right? So in this case, the output will not be in terms of classes or categories. So that comes under only when you're learning about classification, right? But if you're going to learn about regression, you're going to the output will not be in terms of any classes or categories, but it will be a numerical value. And what type of numerical value? It will be a continuous numerical value, isn't it? So, for example, so it mainly answers the question of how much and then how many. So we can take an example of we can have two. What is that? One input and then output. So input can be the number of hours you study, and the output can be the marks that you get. Okay, so it doesn't mean that that if two people, let's consider if two people put the same number of hours, it doesn't have to be that they have to get the same marks, right? It does vary a lot, right? Isn't it? So here, in the same way, or depending on the, let's consider this one as well. If you want to find the house of like price of a house, okay, depending on the location or depending on the number of bedrooms and bathrooms that you have, it does really change, right? So here you will not be having any kind of constant value or a classes. So we are going to get into this regression value only if you want to predict or take a decision on any particular input data that you give, and the output that you're going to get is it will be in terms of a continuous numerical value. Is it clear? Just because two people are putting the same number of hours to study, it doesn't have to be that they might get it, but is it damn sure that since they put the same amount of hours, that does they have to get same 90 marks or same 80 marks? It does vary a lot depending on the person, right? Isn't it? So we're going to use this regression concept where we're going to training on the label data, and we're going to have the output in terms of continuous numerical value. Is it clear? And it is going to definitely what does it give you the answer for how much and then how many. Is it clear? I hope it's clear, right? So not only we can take an example of sales forecasting. So it differs from year to year, right? Depending on the number of sales, so depending on the number of the quantities and the number of people who are buying that product, it does really affect a lot, right? Doesn't have to be that since I'm having the same number of customers or since I'm having the same number of quantities, I will not get the same number of sales, right? Or you can take the like we have this economist, right, in our company, sorry, in our country. So how do they predict? They're going to predict the GDP, isn't it? How are they going to predict the GDP based on the current data that we have? They're going to do some analysis, bring in some lot of regression models. Based on that itself, we will be able to predict a numerical value, not a constant one single value of one class. Is it clear? Or let's consider the IPL itself. So IPL, we have so many things to consider, right? If you want to get selected for IPL as well, there will be so many metrics that they're going to consider, isn't it? So based on this, they will be able to take a call. Like we will be seeing this what is that? A picture, right? Average in OD, average in T20. So how are they able to see it? They're able to get it. Average, if given one match, he's able to hit around 50 runs and 50 runs a match or 60 runs a match. How are they able to predict it? All because of this, using this regression concept. Is it clear? Excuse me, guys. So what are the real life examples that we can consider, like predicting the price of a house? So here, what are the things that you can consider? You can consider the square footage, that is the size of your whole building or your home, and the number of bedrooms, bathrooms, and mainly it also depends on the location where you stay, right? So if you're going to stay in the city, you will get you will be asked to pay more, isn't it? And what you can consider, you can also consider the age, how much how old is your building. So depending on that, your what is that, finding the price differs, right? Next, coming to the student score. So it does differ a lot, right? The how much time does it have to does he spends to study, and attendance also matters, right? So for backbenchers, it doesn't matter because they're going to use it the last 1 week or last couple of days to prepare and write the examination. But if a student is attending class every day and is listening to the class, he will have a more impact on the exam, right? Isn't it? and we also do conduct quizzes, right? So depending on this, what we can consider, as he's attending the classes and attending all the quizzes, we can share that since he's attending the classes and attending the quizzes and all, we can assure that since he's doing these things, we may expect to get him to get a marks of over 70 marks or 30 or 80 or 90 marks. Is it clear? Next, next thing also coming to the temperature. So what can we do depending on the historical weather of the geographical location or the ocean currents, the flood the airs that comes, right? So depending on these things, we will be able to what is that get to know about the temperature, isn't it? It is not we will be able to predict depending on these things, depending on these numerical terms, we will be able to predict what could be the temperature. Is it clear? Next, also coming to the predicting the sales figure for the next quarter. So how are they able to predict it? Based on the data, whatever they have, they are able to find some patterns or find some analysis. Based on this, they are able to predict the future. Okay, they might be able to predict the future, or they might be able to get a count or get a value of the profit. Is it clear? So everything happens. If you observe, the only thing that is common between all these examples are here your output is in terms of numerical value. And numerical value meaning you're not having one fixed value, you're having continuous numerical value. It does differ a lot from person to person, from company to company, or each metric. Is it clear? Now, let's get into this linear regression. So what is this linear regression? Any idea? Yes, guys, any idea? Let me go to the chat. Yes. Linear regression is yes, one input and then one output. Why linear? Means you will be able to find some relationships. Okay, either if a person puts lot of more or less, if a person puts 5 hours, you'll be getting more marks, and if a person puts less number of 2 hours, he will be getting a less marks, isn't it? So here, for each value in your x value, you will be able to predict the value of y, right? So here your data is linear, meaning you are able to directly draw one particular line which is going to follow this equation of m is equal to what is that? Y is equal to mx plus c, isn't it? So so when are we going to use this linear regression? Only when you're having a one in what is that? When your relationship with your input value and their output value, it is linear. Like if one increases, the other one also increases. Depending on that, you will be choosing a one perfect line that is going to what do you say? Given any kind of value, you will be able to predict depending on that line. It's clear. So, but how to draw that line? Okay. So the difference between the simple and multiple is if you have one input and then the one output, that is called a simple linear regression. What if we have multiple? For linear regression, for the linear regression, we can take an example of number of hours you study and the marks that you get. Okay, and for multiple linear regression, what you can consider is you can predict the price of a house. So what are the things that you're going to consider? You're going to consider the location, square foot, the number of bedrooms and bathroom that you have, isn't it? So these are multiple things that you're going to consider to get the output value, and the output value is also continuous numerical value, right? Isn't it? So this uses a linear equation. What is that? Equation of a straight line. So what does this equation of a straight line mean? So here, whatever the output that we're going to get, that is the target, the continuous numerical value, right? It does depend on this y is equal, that is mx plus c. So if you see here, y is the output value that we know. Okay, that predicted value that we have got from this x and then mx plus from this value of slope x and then c. So whatever the x value that we have, right, that is our input. So here we have this input of the number of hours that we put to study, right? So that will be whatever value that comes under this will be under this x value. So what does this m? So m, we will be able to find the slope. So what does this slope means? For each value in x, what are you able to see the changes in y? Okay, but to find that, we are going to have this m value. Next, we have the c. So what does this c means? It is the y-intercept. So y-intercept means at the value of x is equal to y is equal to 0. So x is equal to 0. What is the value of y? Okay, to find that we're going to have this C. Is it clear? So you have to understand that as you have usually the input value that whatever you're going to have, you're going to change it with this X values. Is it clear? Now let's take an example. So here we are having a simple linear equation, right? Linear regression. So here we are having age and the height. So as age increases, your height also does increase, right? So to find that, you should have a slope and then y-intercept. So how do you have the slope and then sleep? We have this formula called as m is equal to n into summation of x and y minus summation x and then summation y, and then this is the slope formula. Okay. Similarly, we have this formula for y-intercept as well. So you have to find these values and then put these values into this formula and then get the value. It's clear? Now, whatever the calculation that is happening here, you will not be doing it in the programming value, in the programming. Okay, you can directly ask the coefficient of x. Okay, and you can also ask the y-intercept. Automatically, just one line, one code will be more than enough. Okay, but you should understand what is happening at the back end, what is the mathematical calculations, right? Isn't it? So these are all your x values, these are all your y values. Now you will be finding this x value, meaning you'll be finding the summation, meaning what? 5 into 105, 6 into 108. So you will be summing all this and then multiplying with the n. So how many numbers do we have? So here we have 6, right? So that you will be multiplying. In a similar way, you have to find all these values and put this into this formula. Okay. So once you're going to do that, you will be able to get the m value and your c. Is it clear? First, you have to find the summation of all these things. Okay. Then put all these values into the formula. Then you will be able to find the m and then c value. That is the slope. Slope is very, very important. You will able to know for what is the value of x. So given a value of x, what are the changes in y that you're able to see? If you want to find that, you will be calculating this m. Is it clear? I hope this calculation is clear, right? So initially, go to this formula, have this note, and then come back and then do all these calculations, put all these values into this formula. Then you will be able to get this m and then c. So this will be common. Is it clear? Now, since you've got to know your m and then c, so what are the input that you're going to give? This is the regression line that you have. So even any new data that you have, and now you want to find your height. Okay. So here what I've considered, this is the equation, common equation that you can consider based on the data whatever you have given. This is This is the linear equation line that we have got. So given any input, okay, either it can be age of 15 or 20 or 30. So given this x value, you will be able to predict the height of this person given an age. Is it clear? So here, what have I considered? I have considered I am trying to predict the height of a child who is of 11-year-old. Okay. So here, what am I doing? I am just giving the value of 11 to the value of x. Is it clear? And I am able to find the height. Is it clear? Is it clear, guys? Clear about this? First, linear regression is only going to have one independent and an output variable. So to find this best line, meaning if you want to find how are these two things related, okay, either it is going upward or downward, you have to find this linear equation, okay, equation of a straight line. So how to find the equation of a straight line? You will be having this formula to find the slope and then y-intercept. So after you have got all this calculation, put these values into the formula, then you will be able to get your m slope value and then y-intercept. Now, given any new data point for this regression line, you will be able to predict the height of the person. Is it clear? Now, as you see, it is you are able to draw a straight line that is going to touch all the point that you have, right? Isn't it? So it is happening all because of all this best line, that whatever we have got this y is equal to 3.37 x plus 88.05, right? This is the line. So even new data point given to this, you will be able to predict the height. Is it clear? So in case of linear regression, what you have to do is you have to make sure you're going to draw a line. Okay, you have to draw a line that does touch all the data points that you have, that does touch all the input value that you have. Is it clear? Now we have this next thing called as multiple linear regression. So what are these multiple linear regression? Multiple linear regression are nothing but you will have many inputs, like many input variables, and only one output variable, right? So here what have we done? We have considered the input values as what are that? Size, bedrooms, and the location, right? So these are the things that is going to consider. By considering these things, you will be able to predict the price of a house, isn't it? Yes, is it clear? Yes, sir, share. Now, this is what I was talking about. So previously we had this y is equal to mx plus c, right? So in the similar way, we have this formula called as y is equal to beta naught plus beta naught x1 plus beta 2 x2 plus no, it goes on and until bn dot xn. So what are these? B are nothing but it's you can consider the slope value that you can consider. Okay, for each value of x, you're able to see the we have this y is equal to mx plus c, right? So we had this m for each value in x, you are able to find the change in y, right? The similar way, you will be getting to know this value of b naught, okay, for each input value that you're going to have. Is it clear? So initially you would have only input values. When coming to multiple linear regression, you might have multiple inputs to be considered. Okay. So what are these B naught and then B2? So these are all the coefficients for your input variables, input values that you're going to give. Okay. So you can, if you want to consider this x1, you can consider as x1 as your what is the number of bedrooms that you can consider. You can consider x2 as your the age or the what do you say how old is your home, or you can consider x3 as your number of bathrooms, isn't it? So depending on these things, so everything will have your impact. Okay. So once you have all these things in your hand, you can just put it into your linear equation and then find your answer. That is your the value. That is nothing but this predicting the house of your price depending on these input values. Is it clear? So you will be finding, you will be getting to know the change in each, like you will be able to find the value of your y. आपको तो आउटपुट पता होना है ना. So each price का कितना अफेक्ट कर रहा है, सॉरी लोकेशन का कितना अफेक्ट कर रहा है, मतलब नंबर ऑफ बेडरूम्स कितना अफेक्ट कर रहा है मेरा प्राइस में, और number of bathrooms कितना अफेक्ट कर रहा है. So depending on these things will have they will have their own m value, right? Slope value. So those are nothing but this b0, b1, b2, then bn. Is it clear? So once you have all these things, you will be putting into this equation and then finding the best value given a new input values. Is it clear? Is it clear, guys? So just understand. So these b0, b1, and b2 are nothing but beta. Sorry, b1, b0. These are nothing but these. You can consider the coefficients, or you can also consider that as the slopes for each of your input variables that your inputs that you have. Okay, and you'll have this b, you'll have this y. So how will you get the y? Once you get the values of all these b0, does that b0 is nothing but the constant that we had, isn't it? So we had the c, right? Y is equal to mx plus c. So that c is nothing but this b naught, beta naught that we are going to consider. So apart from that, we have beta 1, x1, beta 2, x2, until beta n, xn, right? So these are all the x1s are nothing but input variable inputs that you have. And beta naught is nothing but the coefficient or this slope that you can consider for each inputs. Okay. So once you have this, you can just put it in the equation of a line and then find the y value. That is the output. Okay. I hope it's clear, right? So here it is not that since we are going to use a particular regression model, we are going to get the exact correct thing. It does differ a lot, right? Let's consider, I might consider, what you can say, if I'm going to consider a particular task would be, I might expect, okay, I might predict, what I can say, I might predict the given task might take up to 30 minutes to complete. Okay, I might predict using a model, but given I am a very, what is it, I'm a very workaholic guy, okay, and I do it within 25 minutes. Okay, I predicted that the task might be completed between up to 30 minutes. But since I'm very enthusiastic, active, and all, I will be able to complete that task within 25 minutes. So here you are able to see some differences between your predicted and your actual thing, right? So whatever the difference that you're able to see, that is called as error that we can consider. Is it clear? Clear, guys? Or you can take an example of you can given the values. What do you say? Given the number of bedrooms, bathrooms, and the square foot, the size, the location. Given these values, you are able to find the price of a house. Okay, by having all those values put into this equation, that is beta naught plus beta 1 x1 plus beta 2 x2. You're able to get some value. Meaning what? You're able to predict using this linear regression model. That is multiple linear regression model. But you have to check that with the predicted value, right? Sorry, actual value. So we did this with the classification report, right? Or confusion matrix. So what were you doing? We were using this classification confusion matrix only to find how accurate we were, how good were we to classify both the classes or be it any classes, isn't it? We are only comparing with what do you say, the actual value that we're going to have, that is y test and Y prediction. What is Y prediction? The prediction that we have done based on the model that we have used. Either it can be KNN classifier, decision tree classifier, SVM, SVC classifier. Yes or no? The similar way, if you're finding any kind of error between your actual value and your predicted value, is it clear? That is called as error. Is it clear? So I also took an example, right? A particular task might take 30 minutes to complete. Okay, you might predict that a particular task might take 30 minutes to complete, but given me, what I'll do is I will be delaying it, and then I might delay it and then finish the work after 35 minutes. So what does it show? You're having some kind of difference between your predicted value and your actual value, right? So this is nothing but your error. Okay, so what we have to do, we have to make sure we have to minimize that. Is it clear? We have to we have to reduce the error. So by doing that, what you can say that our prediction is perfectly good, or we are clearly whatever the prediction that we are making, that is what is happening. Is clear or not? So what is an error? So it is the difference between your actual value and our predicted value. Is clear? I hope it's clear, right? Okay, let me go to the next slide. So next we have this cost function. So what are these cost function? Cost functions are nothing but these are used to find the how much of error. Okay, so here we have three types of errors. Okay, to find how much is the difference between our actual value and the predicted value. So here we have to consider this average of squared errors. So why do we have this average of squared errors? Here we will be able to get not any kind of negative values, and it is mostly sensitive to all your what do you say, outliers. So not outliers. If you have any kind of value bigger than, which is bigger in value, you're able to get that not having any kind of negative values, only positive values will be done. Okay, so here also what this xi is nothing but our actual value. Okay, and y I cap is nothing but our predicted value. So here we will be able to find the error itself, difference itself. It's clear. This is one way. The other way is finding this root mean square error method. So what are we going to do is here, let's consider you have an error of 100. Now you want to make it simple. You're worried about the number of the value that you're getting. It is very big, or you're not sure what is the unit that you're getting. So to reduce that, what you're going to do, simply if you have this square root, you'll be able to have a one standard value, or is that one constant value that you can consider, or a standard value, which by looking at that, you will be able to analyze, or you will be able to get to know how much is the error. Okay, like if you have an error of 100 to 100, then having this square root, you will be able to see that you're getting around close to 10%, isn't it? Now, last we have this mean absolute error. So, what is this mean absolute error? This is very, very, so if you have any kind of outliers, okay, so it is very, very, what do you say, advantageous by using this mean absolute error. So, here you're not going to do any kind of squaring or what is that, square root or finding the root mean square. Okay, you're only going to have deal with only your predicted value and actual values. Here, whatever the output that you get, it will be only in terms of positive values itself. So the first and foremost thing that you have to keep is when you're going to use this cost function is you have to make sure you're going to choose to minimize your error. How are you going to minimize your error? By changing the values in your beta mart. Okay, b values. So by using this MSC, it is not that you have to choose the MSC or root mean square itself. You have to check with all those things, and then whichever it's going to give you the what is that below the lower one, you can consider that. And if you're having more number of errors, you have to take some hyperparameters tuning and all, and then meaning you by doing that you will be changing the values of your parameters, and then get to know your error. It's clear, guys. Can we get the this PPTs for the reference? PPTs PPTs does have a small information, but what I will do is I will share you the notes, okay, in a document form like my Google document. So there you will be having what is that clear to clear or the crystal clear notes, okay, whatever we have learned today, okay. Any questions, guys? I think it's clear about KNN and then regression, right? Time permits, I'll share you this code as well, or else by end of the day, I'll share the code in our Google Drive. If you have any kind of queries, just let us know. The Q&A. So what, since we have got to know about clear understanding about what is classification and regression, we can now directly dig into our unsupervised learning, that is clustering, and then we have dimension reduction, PC, and all. Hotline Kushi, I didn't get him. Drive link, okay, no problem. By end of the class, I'll share it. Okay. Yes, guys, it's 3:03. You can take a break for 5 to 10 minutes, and then after that, we can resume the class. Okay. Hope Pratik and others has also joined the session. Yes, guys, you can take a break. So yes, guys, can we resume the class? Everyone are back, right? Just confirm if I'm audible first. Yes. Okay. Well, guys. Yes. Yes. We can. Let's go. So let me share the yes. We did had a couple of introduction class regarding machine learning and all, right? And I did talk about what are these unsupervised learning and all, isn't it? So can anyone please remember, just recollect what you understand by this term unsupervised? If possible, can you please give me the example with the examination I told you? I'm going to do that, yes, don't worry. By the end of the session and before I'm going to end the session, I'm going to share you the drive link. Don't worry. Yes, now, for now, just tell me what do you understand by this term unsupervised? Try to find the patterns. This the unlabeled data. Correct? Any other thing? Unsupervised type of machine learning. Yeah, algorithms learn from unlabeled data, seeking to discover hidden patterns, structures, relationship without explicit guiding. Okay, cool. As in the textbook, as in the outside, you have been correctly mentioned. What about others? Yes, no target. It is like children classifying objects based on the color, shape. Correct. Absolutely correct. So now let me share my screen. But before that, guys, can you please confirm me if my screen is visible? Thank you, guys. So, so before we directly dive into unsupervised learning, let's consider an example. So everybody would have come across this term called as I can say. Let's consider an example of. Let's consider I have a child. Okay, so I'm very busy. So I have some work to do. So I will be giving a colored balls to my children. Okay, so what they will be doing, let's consider I have given it in the box. Okay, so this box has colored ball. Let's consider red, blue, green. Okay, so initially she might not be able to classify, she might not even be able to understand what is this and all, right? But once it is thrown on the floor, okay, once it is thrown on the floor, will she not be able to get some patterns, or will she not be able to identify some structure, pattern, colors on the size or something? Does do it, right? So that is what is going to happen in our unsupervised learning. Okay, so initially you will not be able to find any kind of input or an output. So what you will be doing, based on whatever the data that you have it in your hand, you will be finding some patterns. Just like the student, just like the children is going to find the pattern. It's nothing but the finding the colors or the size of the ball, isn't it? They all depend on this. Based on this, they will be able to segregate them or classify them or cluster them, isn't it? So that is what we're going to do it in unlabeled. What is that? Unsupervised learning. Or an example, yes, we took an example for examination, right? In case of a supervised learning. So in case of supervised learning, what did we do? We were given a set of 10 questions. So based on the learning, whatever we have done on this 10 set of questions, if asked any out of those 10 questions, you will be able to answer, isn't it? So you have been trained with a given a question and also answers. So once in your examination, if any questions come related to the 10 questions, you will be able to answer, isn't it? Now, you're like a backbencher. Okay, you don't follow any kind of you don't depend on anyone. You literally follow on the textbook or the last minute learning. So what you will do, you will be learning on yourself, isn't it? So in this case, you will not be having, rather than looking at the important questions, what you will be do, you will learn, you will get you will get to learn all the textbook contents. So textbooks lo textbooks में full पढ़ेंगे आप. Okay, so just because you have studied the full content in textbooks, you will be in a place to answer any kind of questions. How will it happen? It will happen only if you have learned the patterns in your textbook. It's clear. So that is what is going to happen in our unsupervised learning. Okay. Nothing. Wait. Yes. Is it clear, guys? So here in this unlabeled data, we will not be having any kind of targets or known output. But given the input that we have, we will be able to find some patterns, identify, be it the shape, be it the color, or any kind of size. Depending on that, we will be able to cluster given a new data point. Is it clear? So it is also similar to the example where if I want to, rather than you, teacher providing you the question followed by the answer. So here in case of unsupervised learning, you will be learning the whole thing, okay? Meaning you will be understanding the pattern, what are the type of questions that you're going to get, okay? So based on this, whatever you have learned, you will be able to answer. Is it clear? Whenever you get this unsupervised learning, you have to get that this comes under, you will be working on your unlabeled data sets. That is without the labels. So labels are nothing but the target that you can consider. Is it clear? So here we have what we can say. Here there are multiple types of clustering. Okay. So what are those? First, what is this? So what is unsupervised learning is? It is learning. You're making the machine learn without providing you the outputs, without us providing the outputs, isn't it? So in this, we have two types of algorithms. One is clustering and the other one is dimensional reduction. Under this itself, we have PCA as well. But let's understand this one. So what is our goal in supervised learning? It is to find the hidden patterns or structures or the relationship between the data. Okay, like you might have 4 columns. Okay, in those 4 columns, you will not be having your output, but by analyzing or but looking at your columns, you will be able to create some new columns, right? So that is what you're going to do in this unsupervised learning. Okay. Now, how many types of clustering do we have? We have 2 types. Sorry, how many types of unsupervised learning we have? We have 2 things. One is clustering and the other one is dimensionality reduction. So in the word clustering itself, we are able to understand. So you will be clustering or you will be, what do you say, grouping particular people based on the similar characteristics. Okay. So for that example, we can take an example of your college. Okay. So you have been divided or you have been made clusters depending on your CSE, ECE and EEE, right? So how are you being able to join into these groups? Since you have a great interest, okay, and you have been, what is that, planning, or you have been dreamt of becoming a software engineer or another electrical engineer, yes or no? So to have these, first thing is they will be collecting all your data. So what are all your interests and what are, if you have attended any workshops related to ACE or EEE or these things, yes or no? So similarly, what do we have to understand is we have to understand what are the similar characteristics that a particular group has. Okay, if a particular group has a particular characteristics, then that can be called as a one group or a cluster. Is it clear? Next, we have this dimensional reduction. So what is this dimensional reduction? So in the word itself, it's there, right? So you're going to reduce your dimensions. So instead of considering, let's consider you have around 100 records, 100 columns. So in that, it is better to remove the column that doesn't have much impact, right? Isn't it? So that is what we're going to do in our dimensional reduction. So rather than considering all the features, so all the features are nothing but the input values that we have. Okay, the input that we're going to give. So it is better to remove some of the columns or the features to have some good clarity. Is it clear? I hope it's clear, right? Now moving to the next slide. We have this examples where we're going to see our unsupervised learning, where we have this customer segmentation. So customer segmentation, we're going to what is that cluster? Meaning we're going to group a particular people based on the customer reviews that we can consider. Or what are you trying to do? You're trying to group the customers based for your targeted marketing. Because if you're trying to what is that target people for your marketing, you will be choosing if you're having a company or if you're having a business, your only focus is to find the rich people. And to find these rich people, you will be first getting all your data, like what is your income, what are your hobbies, what do you do, where are the things where you're going to invest your money. So these are the things that you're going to consider. Based on this, you will be able to segment. He might be belong to a poor guy or he might be belong to a rich guy. Is it clear? In a similar way, we're going to go for anomaly detection. So what is anomaly detection? It is to find the patterns. It is to find some unusual patterns, meaning whatever the transaction that you're going to do, whatever the transaction that you might take. So initially, by default meaning like every day you might have a transaction not more than 1,000 or 10,000. But suddenly, if you have transaction more than 1 lakh or 10 lakh, so this is an unusual behavior in a transaction, right? So in this case, if you have these kind of things, you can analyze this by using this unsupervised learning. Next, we have data compression as well. So what is the data compression? Rather than having this uh, having so much of data, which has having so much of data, it is going to lead you to confusion. So it is better to have remove the inconsistencies or remove a column or remove data which is not have much impact, okay, or which is not going to give you any kind of idea, okay, or which is not going to give you any kind of analysis. So it is better to remove those data set and have only the data that does provide or that does have much impact. Is it clear? Next, also we have this topic modeling. So what is the topic modeling? Here we are going to, what is it? Identify the themes in the next the text documents. Meaning what? You want to identify all the keywords that you can consider in your text documents. So in this, all these applications, what are we trying to do is, here we are not given the what is the target, but what are we trying to do? Depending on the input value that we are able to say, that we are able to having, we are able to get some conclusion that he might belong to this class, or he might belong to this cluster, or he might belong to this cluster. While coming to dimensional reduction, it is to it is to have only important details with you. Okay, it is to have only the data that has much impact. It's clear. Rather than having all the data, it is better to have some data that has more impact, that is has much impact. By having this data, you will be able to do some analysis. Is it clear? Any questions, guys? Yes, is it the same? Are you guys not able to see my screen? Please confirm, guys. You're able to see my slides moving, right? And what about my audio? Is it fine? Yes. Then viral, please check your internet connection, because some of others are able to listen to me. So if you're not able to listen, it is just purely because of internet connection. Please make sure you're going to have a good internet connection. Okay, Manisha. Yes, Manisha, you too, please connect to a good Wi-Fi. Now, let's go to the next slide. So here we are going to talk about the first type of unsupervised learning, that is clustering. So what we are going to do is we are going to cluster, or we are going to group a similar characteristics people. Okay, so how are we going to do it? Here we are going to have some algorithm. Okay, it is, we have some algorithm. What is algorithm? Is to find the patterns. Okay, so these patterns will not be, what is that, given to you at first time. Okay, but using some calculations or using some algorithms, you will be able to find some patterns. Okay, so how will you do it? First thing is you will be looking at the characteristics. Okay, or you will be finding some qualities that has, like, people with common characteristics will be in one group, right? Just like similarly in your college, you will have the same what is that, interest to do in CSC people. If you have a, what is that, if you have a thought to do your BTech in CSE itself, you will be asked to, you will be joining to the CSE group itself, right? So here what are we trying to do? Here we are able to group the students depending on the interest, be it in CSE, ECE, or Triple E, isn't it? So here also, depending on the data that we have, so we will be looking at all the data points, and we will be able to find the patterns in each of these. We will be able to find the quality or the characteristics given the data points. Okay, after we have learned about the characteristics, so we will choose the respective new data point to be in that particular cluster. Is it clear? So how to do that is, we are going to use this concept called as k-means clustering. So what is this k-means clustering? So here first we will go to identify, meaning first we are going to assign, हम पहले कितना centroids हमको चाहिए, कितना clusters चाहिए, उसको हम select करना है पहले. So after we are done with this selecting our k, how many clusters, what do we have to do is we have to find some characteristics. How do we find it? We are going to use this. Similarly, we have this k-means classifier and then regressor, right? What did we do? We used our distance formula, right? In the similar way, what we are going to do is, initially we might not have, so पहले हमको पता नहीं था कि कितना कितना क्या क्या cluster है. So but you have to take the decision. You will be having only 2 clusters or 3 clusters. Okay, it is up to you. Okay, so to have that, so each cluster will have a centroid. Okay, what is the centroid? Centroid is nothing but the center point. Okay, but this center point, you will be able to calculate the distance. Okay, so calculate distance, calculate करने के बाद you will be able to put the new data point in the respective cluster. Okay, so clusters are nothing but the different groups that you can consider. So each of these groups will have a centroid. So what are the centroid? Centroid is nothing but your point in that particular group. Okay, so initially let's consider an example of this one. So here we have scores as 10, 12, 15, 30, 35, and then 40. So here how many points do we have? We have 6 points. Now we want to cluster these. Now we want to group these points into 2 clusters. Okay, so here I have considered the clusters as 2, right? So that is the k value is equal to 2. So here what initially what we पहले हम क्या कर सकते हैं, मतलब we can take any random values. Okay, that is the centroid. Okay, here what am I doing? I have considered only 2 clusters, right? If I have 3 clusters, k is equal to 3, I have to consider 3 centroids. Is it clear? So since I consider k is equal to 2, meaning this will be the center value for each of these clusters. Okay, so here I have considered 12 as the centroid. Okay, and 35 as the second centroid. So with these 2 in my hand, what I will be doing is I will be finding the distance. Okay, and then finding which cluster does the new value belong to. So to help you understand that, so how does this happen? First thing is, you will be, don't worry guys, just follow the steps. If you're not able to understand this, you will definitely be able to understand when backed up by numerical calculations. Don't worry. So I'm just going to tell you the procedure, the steps. Okay, so first thing is, you will be initializing your centroids, meaning what? How many clusters do you need? Okay, or how many clusters do you need? Is it clear? Once you assign these, so what do? You have to assign these each point data to the closest centroid. So what are you going to do is, you have the centroid set the new value. with this new centroids, you will be finding the distance formula. So once you have found the distance formula, and then you will be looking at the nearest centroid. Okay, so क्या centroid आपको पास रहता है उसको उस क्लस्टर में डालना है. Okay, so how do you do that? You're going to find this closest by having this Euclidean distance. So what are this Euclidean distance? There's nothing but square root of x2 minus x1 minus y2 minus y1, right? The whole square, sorry. So next, what do? You're going to update the same thing until you're going to update. You're going to have new and what are the centroids. Then how will you, until when you're going to complete all these finding the distance and all? Only when you see your clusters not changing. Okay, so it is better I explain the problem first, then come up and then explain the steps. So initially, let's consider what is a data point. Here we have data points as 10, 12, 15, 30, 35, and 40, right? So in this, I've considered two k is equal to 2 clusters. That is two centroids. One is C1 is 12, another one is 35. So what does the C1 represents? This represents the first cluster, isn't it? So now what I have to do? I have to find the distance formula, right? So here, what am I doing? I'm finding the Euclidean distance. That is y2 minus y1 and then x2 minus x1. So in this case, what am I doing? What is my value of first value? It is 10. Why 10? That is the first data point, right? Next, what is the first centroid value? C1, that is 12. So now you're finding the distance, isn't it? So 10 minus 12 is 2, and similar to C2. For C2 is what? 35, right? C2 is my next cluster, that is 10 minus 35. So what is the output? In case of C1, you have 2, and in case of C2, that is cluster 2, it is 25. So 10 number, is it close to 2 or 25? It is closer to 2, right? Because 10 is very closer to 2, isn't it? So in this case, what we can consider is this data point can be put into the cluster of C1. Is it clear? No? So let me explain you. First thing is you have to identify, you have to set how many clusters or how many groups you want to have it. Okay. Next, you have to choose the centroid. What is the centroid? It is the central value that you can consider. It is up to you. You can choose anything. Okay. So once you have chosen it, you have to find the distance. So what is this Euclidean distance? It is to find the distance between your actual value and your centroid. So how does it happen? Consider the first data point. That is the 10, right? So here we have data points as 10, 12, 15, 30, 35, 40, right? So these are the data points that we have. So you're going to use this Euclidean distance to find the that value. So once you're going to find this Euclidean distance value, then you're going to see the data point and the cluster. So here what have we done? We have considered this 10 as the new value, that is the value from our data. Then 12 is the centroid value. Now whatever the output that we have to get, okay, here we have got 2 and then 25, right? Now you have to compare the score, what are the input values that you had, right, with the clusters value that you have. Okay, so does 10 belong to that? Does 10 is close to 25 or is it close to 2? That's definitely close to 2 itself, right? Meaning what? This 10 belongs to cluster 1. Is it clear? Now let's go to the 12 value. So now we have this distance formula. What is that? 12 minus 12. We have got 0, and then 12 minus 35, we have got 23. So is 12 close to 0 or close to 23? It does definitely be close to 0 itself, right? Isn't it? So hence this 12 belongs to cluster 1. Next we have this 15. So what is this? We have 15 minus 12, it is 3, and then we have 15 minus 35, it is around 20. So does 15 close to 3 or is 15 close to 25? It is definitely close to C1 itself, right? 3 itself, right? So hence it does belong to this C1. Then we have to find the lowest value. Is it clear? So once you have found the value, the distance value, you have to choose the minimum value. And after choosing the minimum value, you have to check what does this minimum value belong to the cluster. Which cluster does it belong to? So here, since I am getting this low value as 0, sorry. So what we have to do is we have to find the distance. So once we have find the distance, we have to check for the lowest number, lowest value. Okay. And after we have found the lowest value, we have to check the centroid. In which center does it belong to? Does it belong to C1 or does it belong to C2? So as this, if you're going to compare this 2 and then 25, then what is the lowest value is 2. Hence, this 2 will be considered as the C1 will be considered for this 10 value. Next, we have this 12. So after we have found this distance formula, then we have this 0 and then 23. So since 0 is the lowest value, we are going to look for this. We're going to have this 12 for this C1 itself. So similarly for 15. So here, since we have this 3 as the minimum value, we are going to look at this cluster. What does this 3 value belong to? That is 12 value. So it does belong to C1, right? So similarly, if you're going to go for 30, we are going to find this here. What are we trying to do? Here we are trying to find the distance itself, right? So here, since the value is 5, since the 5 is less than 18, you have to choose this 30 for this cluster 2. Here. Now, the similar way, so you have to make sure once you have solved this distance formula, you have to choose the less number. Okay, once you have chosen the less number, you have to identify which class does it belong to, which centroid does it belong to. Okay, that centroid you have to give it for that particular point. Okay, so similarly, if you're going to consider for the 35, you will be getting this value. Since you have this low value as 0, you're going to choose that respective cluster. Sorry, centroid. So here that 35 is going to belong to the C2 itself. Is it clear? Now we have this updated value. So this is your score, right? Isn't it? For the C1, what is the new value? You have 2, isn't it? Next, for the value of C2, what do we have? We have 12, isn't it? Considering for 12, given your first C1 value is 12 and then C2 value is 35. Is it clear? Based on these data, you're able to see that since this is of value of less value, you are going to consider this new data point for this C1. In the similar way, for 0 and then 23, since the less value comes under C1, you have got to assign this value for this C1 cluster itself. So similarly, you're going to do it for C2 as well. How we're going to do? We're going to choose the minimum value and then find that cluster assigning to that new data point. So until how much time you're going to do it? Until what are you going to do? This is a new centroid, right? So here, what you're going to do is once you have got to know about this center, initially you would have taken 12 and then 35. Now you have got these two new centroids. How do you have to assign these two centroids? Is you have to find the average. Okay, average of 3 C1 clusters and average of 3 C2 clusters. So how are you going to do it? You have to look. So कितना C1 आया है, कितना data points हमको C1 में आया है, वैसे ही कितना point हमारे को C2 में भी आया है. So if you're going to consider C1 and then C2, like C1 we have 3 data points, right? That is 10, 12 and then 15, isn't it? So if you're going to find the average, that will be the value for C1. That is the new value for C1. So initially you might have considered 12. But now since you have got your clusters, what you will be doing is depending on the cluster that you have to find the average for the respective values. Is it clear? So it has to be the C1, the new C1 value for the new C1 value would be addition of these one divided by the number of items. That is 10 plus 12 plus 15 divided by 3. That is finding the average. So that will be the C1 value for the new one. Okay. Similarly for C2 as well. That is C2 is this one, right? The last 3, that is 30 plus 35 plus 40. So you have to find the average. So that will be the value for C2. Is it clear? So how to find that? This is how we do it. So initially we would have, by default, we would have taken any number as a centroid. After we had done this some kind of repetition, we will be able to get the clusters depending on you might have, let's consider, you might have the first two can be C1 and then C2. The remaining can be C2 itself. In that case, what you have to do, you have to find the mean of the first two. That is 10 plus 12 divided by 2. So that will be the value for the C1. And the remaining 4 will be the value after finding the average of these 4 values. You will have the value for C2. That is your new centroid value. So now with this in your hand, what you have to do? You have to do the same thing for the remaining. Whatever you have done right previously, this finding this distance and all, you have to do. So until when you have to do? Until you are going to see no change in these clusters. Okay? Until you see no change in these clusters, you have to do it. Is it clear? Is it clear or not? Now, what will be your this one? New C1 and then C2. This will be 12.33 and C2 will be 35. Is it clear? So this 12.33 will be sent here. Okay. Excuse me. So this 12.33 will be sent here. That is the value of C1, right? So 10 minus 12.33, you'll be getting one value. And then what is the other value? We have 35, right? So you're going to consider C2 as 35. So this will not change. So you're going to find a new value. You're going to get a new value. And based on this new value, you'll be able to cluster it. So you have to do it for all the data points, even this new centroid. So until कब तक करना है? जब तक आपका A value रहता है ना, C1, C2 and then these clusters, this will not have to change. जब तक ये change कुछ भी नहीं दिखाता है, मिलता है, तब तक हम एक calculations करना है. It's clear? First we have to do it, find the clusters. So whichever is the lowest number, we have to assign that a new data point to that cluster. Once you have assigned that, you can put it in the table form. Then after having these, based on these clusters, we have to find the average. Okay, that will be the new centroid value. With this new data centroid value, what you can do, you have to do this calculation until you see no change in this clusters. Is it clear? Is it clear, guys? So why new centroid says it is to what is that? Find more in detail patterns. Okay, it is to find more detail in your data points. I hope it's clear, right? So even after repeating this, yeah, there's an example. So I'm going to repeat the steps 2 and then step 3. What is this? Finding the distance. So if you see, I have got the C1 value, that is the new centered value is 12.33 and the C2 value is 35. So even after applying this distance formula and all, I'm able to see no change in the C2. What is that? Changing clusters, right? Because the value score of 10 is belong to C1, 12 belongs to C1, 15 belongs to C1, and then respective 30, and then 40 belongs to the same cluster section, isn't it? So until when do you have to do it? Until you see no change in your clusters. Is it clear? After until then you have to do it. Is it clear? Is it clear, guys? So to find this, how many clusters? Initially you would have directly taken, right? By manually you might take anything, but systems can't understand, right? The machines can't understand how many cases to be taken considered. So to have that, we're going to have this elbow. What is it? Elbow method. So what is the elbow method? Depending on the data point that you're going to have, it will be able to draw some what is it? Connect the dots. So once you're able to see this, once you're able to see this kind of thing, where you're having this elbow kind of things, like just like you have this. What do you say? Just like we have an elbow, right? That does show some whatever kind of classification, right? So in the same way, if you want to find this number of clusters, here in this example, what does we have? Here we have the distribution of our data. Okay, whatever the data that we have, here we have the distribution. Only when you find this, when you find this, what is that? A bend. Okay, that bend can be considered as your number of clusters. Okay, here in this case, since this we have this data points as 1 to 10 and then anything from 0 to 7,000. So these are the data point that has been distributed in a graph. So you're able to see only this band at this number 3. So here you can consider the number of clusters as 3. Is it clear? So you don't have to worry about this. Just given some code in our code, what is it, Python or in Google Colab, you will be able to find the clusters. It's clear, right? The mathematics part, this is very, very important, as you'll be able to understand. So given the data, you will be able to find the distance. So you'll be finding the minimum value. So after finding the minimum value, you'll be identifying what does this minimum value belong to. Does it belong to centroid 1 or does it belong to centroid 2? So you have to do the same thing for all the things. So after you have done that, you'll be getting a new centroid by calculating the average. Okay. Once you have this average of value, you have to do the same thing, finding the distance formula. And until when do you have to do it? Until you're going to find no change in your clusters. Clear? Yes, guys. I hope it's clear, right? Just give me a moment. I'll just create a quiz for you. Yes, if you have any kind of doubts, you can put it in the Q&A. Wait a minute, guys. I will just quickly give you a quiz of 15 questions. Guys, so please scan this QR code. I hope it's visible, right? So you can scan this QR code, mention your name, and then we can start out with the quiz. Yes, I'll share the drive link as well. Just a moment. You can scan the QR code viral. This is your name. You can keep it for yourself. So click on to this link for the quiz. You are done? Is that the quiz? This guys confirm me in the Q&A. Start the quiz. I'm just going to wait for 1 minute. Yes, Suresh. I don't know who are you making those emojis and all. Is there any particular friend of yours here? I'll just wait for 1 minute and then start the quiz. Start at 4 o'clock. Okay, guys, let me start. So, if others also want to join, like make your own. Okay, 8, 9, 8. And once the quiz is done, you can come back and then mention the same thing. Yes, guys, can I end the quiz? Guys, superb. I'm happy that everyone are having their presence in the quiz. You do follow the same until the last. So let me stop sharing the screen. Back to the class. Yes. Yes, guys. You'll get to know your sir, how we get our results. My test is done. You'll get to know your results when you submit the last quiz. Okay, last quiz questions. Okay. And I'm making it once more clear. This will not have any impact on your performance. Okay. So don't worry. It is just to check your knowledge. So yes, guys. So I'll upload the handouts as well by end of the day. So please make sure you also go through. So tomorrow, if possible, we are going to deal with the remaining algorithms in the unsupervised learning and backed up by a code. Okay. So yes, guys, that's all from my end. If you have any queries, you can just. I'll be here around the corner for 2 minutes. Okay. Yeah. Because I've disabled it. Don't worry. From tomorrow, I'll enable that. Okay. Don't worry. Yes, guys. Thank you so much for your time. So until tomorrow, have a great day. And if you have any queries relating to the content, so I'll be here for another more 2 minutes. Okay. Shreya, I'll not be able to upload. I'm not allowed to upload the PPTs, and moreover, PPTs have only less content. Okay. So what I'll do is I'll share the Word document, which is like your notes. You don't have to go and then make a note from the PPTs. So I'll be giving you in a simple way where you'll be able to understand each concept. So don't worry, I'll just send it in the Google Drive. So hope everyone are having the Google Drive link, right? Okay, guys. Bye. Have fun. Okay, guys, I'll just have a word with our team to share the PPTs. If possible, I'll share it. Okay. Okay, fellow mates. Bye bye.